going to have to clear that out. Okay, show you once more. If you forget what the value of e is, you just put in a second e to the first power, and there's the decimal. I'll just review that, and we'll march on. So up here, instead of b, we're going to have the base e. So instead of having in our exponential growth function that you did in 13.1, and how do I know it's a growth? Because e is about, I was going to put equal, that's a lie. It's about 2.71828. 1828, 1828, like that. So it's that e is bigger than 1, so it's an exponential growth function. So this is a simple lesson because they already give you reference points, or you're going to find the reference points from our past experience, and note on the function where we get our reference points and where we find the reference points for this exponential growth function. So if we're going to write this function whose graph is shown, the transformation comes from h and then a plus k. That's the first reference point. That's the simple one, and we only used this one in our exponential decay function, but the exponential growth second point wasn't so hard to remember. It's h plus 1 and a, but instead of b, it's e plus k. So those are your two reference points. So this is where we find a, right? So we use it in our reference points, either to write the reference points or to write the function. Our h, I think, was green. That's up here in the cozy. What's being subtracted from x. And the k is the asymptote number. And if it hasn't been changed, if it hasn't been changed, then, k is 0. So if this isn't there, k is 0. You remember that. If a is invisible, a would be 1. And if you don't see h, h would be 0 too, as well. So that's the game we're going to play. Now we're having you write the function from the graph. On the homework, you'll just find the reference points and then find the graph. So this is an extra step, and it's not difficult. It's not difficult because you already know what the graph is. You can pull out your parts. The first one you see as you read a book is the first reference point. So our h is 3, and that's all you'll use for this first reference point is the h number. So on the homework, if you want to find h, or if you have the equation, the reference point, h is found on that first reference point. Now, where did they get the 6? They added a and k together. But that doesn't help us any as far as finding a and k. There's a myriad of numbers I could add together to get 6. So that's not going to be unique. But in our second reference point, they took the h, added 1 to it, got 4, which that doesn't have a color because I changed h. Okay, then they took a times e, so they multiplied a times e, and they left them apart. They didn't change e to a approximate decimal to use for a number, so that really helps a lot on the homework. So if you want to find a, it's that multiplier to e. It's that simple. Okay? Then if you want to find k, it's what's being added to E. Fair and square? So the equation, whether they give it to you first or give it to you last, it's A e to the x minus h plus k. A e to the x minus h plus k. That's the game we're playing. So what's going to help us on the homework? They'll give us this. We got to pull out A, H, and K to find the graph. We'll just go ahead and do one if you don't mind here on number 4. We'll see from the graph if we can find A, H, and K. Then we can see where they live in the equation and we can go to the homework. So A is pink. It's the multiplier in front of E. So A is a -1. That's where we find A, the multiplier of E. These are kind of all squished together. But here's the second reference point. Here's the first reference point. And those are just the numbers on the number line. H, we look up into the first reference point. Here, it is what it is. And then K is what's being added to E, guys. It's that simple. Simple, simple, simple. Now this is an exponential growth function that got flipped like a pancake, right? Because if you see my blue graph up there, that is the parent graph, f of x equals e to the x. That's before it got touched. And now this one, we'll call it g of x, because he got changed, is up here, you see a, negative, e, I don't put a 1 there, I don't have to, x minus h, x plus 3, and then plus k. And you're done. So if you wanted color code one more time before we get to the homework, there's A, there's H, and there is K. There's where K lives. Just like it has on all the functions we've worked with. They've either had it popped out to the right or popped in front, wherever it lives, but it's outside the power term, the term with the exponent. That's the lesson. So if you would open your software, please. I'm going to have to use the paper copy because of the, I'm recording, okay? So you can note this if you want to on your pencil and paper, but if you go right to the software, you can apply what we'll be applying is this guy right up here. We're going to be applying this story right up here, okay? So keep this handy. This is where I'm getting my information to do the homework. So go right there. You'll have this 13.3 done today. There's only 11 questions. The first one is how I described how they got E. They took it. This is like a compound interest formula. And they saw as they made x bigger or go to positive infinity, then the value of the function became this 2.7182818281828. I shouldn't probably use that eraser. I'm going to make that a better E. Okay, that's where E came from. They played around with this. You'll just use your typewriter E. There's not a special, this is a drop-down menu. Pick positive infinity. This one, you just type in the letter E, okay? And you can play with this in your calculator, but if you just put in like a 1, then a 2, then a 3, then a 4, then a 5, and you'll see how it just gets closer and closer and closer to that decimal. It's crazy. It's just, yeah, this is what they did for fun, was discover things like this, and then you get to name your number if you can prove it. Okay, the next one is talking about that parent function here. So they said before you start transforming it, I'm going to go ahead and highlight it because you don't need all the words there. Okay, if you are writing this down, the domain remains the same because it is a exponential growth function, and the range is the same because remember, if you're adding a number you don't see out to the right, it's 0. Remember, this is K. Okay, remember that? And so if the function of x is e to the x plus nothing, apparently that plus nothing is plus 0. So if you look at my blue graph over there on my whiteboard, as I go to the left, my numbers approach 0, but it will never cross the 0 line because that's the asymptote. So that's why this is K as well. But if you look to the right, it's going to the moon, isn't it? Rub your tummy and pat your head. You got to look to the right and see which way the blue graph on my whiteboard's going. Now, for the sake of the video, I'll draw a parent graph here. This is 0, 1, because if I put in 0 for the exponent over here, I get 1 out. So it's f of x. I'm going to put 0 in. F of 0 is e to the 0. So f of 0 is 1. That's where I get this y-intercept right here. It never will touch the x-axis, but it does cross at 0, 1, just like any other growth function that hasn't been transformed. 2 to the x, 5 to the x, 10 to the x, 20 to the x. Remember, since e is greater than 0, or e is greater than 1, that is why it's exponential growth function. So all these are stories about this parent graph. Now you know what a parent graph is. We've had parent graphs all along the way. This is an exponential, and you had it on your notes too. Special exponential growth function. Okay, we got that. It's number theory. It's in general. Everybody should have the same story, but I don't know if everybody understands it. You got to chew on this a little bit. Why is this true? That was my job, to help you figure that out. Okay, now your number 3 might be different than mine. And what they did for the number 3 was instead, they have a middleman here. Instead of writing the exact function, they just subtracted 1/2 from the x. So this really means the g of x is e to the x minus 1/2. See what they did? They have a middleman here. This is what you saw in August when we didn't know what the function was. Now we know what the function is. It moves it to the right because that's what h does, right? Correct? Yeah? And nothing else changes. This curve still goes up forever. It goes to the left closer to 0 forever. There's no other effect on its behavior for number 3. So they just threw a middleman in there. Just give you a good time. Have fun with that. Just a different look on how you can transform a function, okay? Now there we messed with the x. That's how we knew it was h. Let's look at number 4. Here they're messing with, technically that's the y, right? So that's how we knew this is k. So if I saw this, if I rewrote this using the function of e to the x, this really is e to the x minus 5/2 outside. So it goes down 5/2, but then that means the asymptote changes, and so the range of this function changes because it approaches, instead of 0, it approaches a negative 5/2. So you put yours in, please. If I know when I was working with somebody, they had different numbers. I wrote down their number because they said their number is very confusing. So be careful. And proofread your work before you turn it in today. It's always worth it, second look. Measure twice, cut once. 4 going, gone. Okay. So what did they do here? Oh, they have a multiplier. So technically, you know, like they're just substituting e to the x in here, but that could be any function, friends. Could be any function, just like in August. They are multiplying by a negative 1/7. So it's a negative 1/7 times e to the x, okay? So because it's 1/7, if I took a 1/7 of you, you would be compressed. It's a, so a equals negative 1/7. And there's that reflection across the x that we know and love because a is negative. I can zoom out a little so I shift it back and forth and make it all fuzzy. Let me do that. That help a little bit. Okay, but the range did change because I flipped this pancake. So the range, what we did in last lesson, all we had to type in was y is less than 0. They went ahead and made it a dramatic set notation with a negative infinity is less than y, which is less than 0. So they just made it a little fancier here. Now, what I did was, if you look over on the board, I drew an orange curve. I'll draw it on here for my video people. And instead of flying up, it got flipped over like a pancake. And the asymptote is the same, so it's approaching 0, but it's vertically compressed, so that means it's going to be wider and shorter, you know, like that, instead of going up at a normal rate of e to the x. So if I put a 0 in here, my y-intercept would be a negative 1/7. Instead of at 1, it's here squeezed up next to the story and the negative 1, 7. Okay, now on the homework, on this homework, we'll see here. We go to number 6. Anybody need more? You see why it's going to negative infinity? If I go positive, see how it's going down? That's why it's negative infinity here. Because a normal one would go positive infinity, but it got reflected across the x-axis is a math word for it. Okay, I'm going to turn it if you're ready. Okay, nope, no graph yet. Must be this the last 3 or so, 3 or 4. All right, we got a stretch going on because 3 halves is bigger than 1. Otherwise, that's all you got. You're really taking e to the x and taking 3 halves of it. See, if I said that was just x, that'd be 3 halves of x. The stretch still happens no matter what the function is. You're still stretching the graph. It's hard to see. It's kind of ugly there. Let me see if I can get it coming back in with our dark room. There we go. Okay. Because 3 halves is greater than 1. Why? A equals 3 halves. Guys, whoa. I was doing so good. Here we go. A writes the story about the stretching or compressing. There's 2 drop downs. Done. Isn't that nice? They're being so accommodating here in this 13.3. All right, this one fooled me because I thought they wanted the y-intercept, but they wanted the ordered pair. So if you remember from our growth pattern, since D was a negative, our transformation is H comma A plus K, right? So up here, H is 0. That's where I got that. We're looking at this one, and we're putting it in here. So our new one really is C e to the x minus D. So A is C, H is 0. Am I still on? Yep, okay. And K is a negative D. So up here, I put in 0, C plus negative D. I goofed when I was practicing. I just put in C minus D, and I was wrong. They want an ordered pair. So please put an ordered pair for number 7. That is, can you read it? 0. I'll write it again. C minus D. Let me get my eraser to make it better. Now, you know, once you turn this in, you can always go back and study it, take notes on it. You guys, some of you guys are really good about that. You don't say one and done. Go back and visit the thinking. That's what makes a true mathematician. You think about what's right. It's nice to know the truth. We're going to get that typed in correctly. Number 8. Here's where we pick the graph. You will like this, you will like this, you will like this to pick the graph. Okay. This is my suggestion to you. You got your story right there. You got a piece of scratch paper. You put A as the multiplier outside. H is what's being subtracted from X. And K is 4. So you plot that out. And then you remember your 2 reference points. They start with the what if this thing hasn't changed. They start with the originals. Don't mind those. That's just what they're doing. They're changing it to H, comma, A plus K. That's where they got the first one. And the second one, they added 1 to H. Pickles, H plus H. That's silly. H plus 1, comma, oh man, I ruined my eraser. comma, AE plus K. So this is where I got my 5 because I added 1 and 4 together. And I got my 4 because that's what I see here as K. Then, you know, domain is what it is, all the real numbers, and range comes from K. So when you go to look for the graph, I always look for the first one first, 1, 5. A doesn't have 1, 5. B does. C doesn't. D doesn't. So all you have to do is find the first one, and then you make sure your second one matches your second one you typed in up here. Fair and square? So that's the story for the next 3. Remember how we get those parts and put them where they belong. And you've just found yourself a transformed E function. And so they'll use this in banking to make some decisions about investments or whatever. That's what this is about. The numbers are raw without a story, but there are stories for everything. So here's my number 9. I got this one from A plus K. See that A is a -1. H is a -1. Oh man, I didn't write a negative on my A, sorry. H is a -1 and K is a -1. What a silly graph. Okay, watch out. They already had the subtraction there. So don't put a -1 in here. Watch out. Remember, you see what I see? I put what I saw here. Domain is what it is, and then this guy comes from the K value. And I already showed you how to find the graph. Look for the, I always use the first reference point first. I look for a -1, -2. I found it, and then that helped me know what I typed in was correct. So they were kind of sneaky to put in that minus there, so be careful. Gotta watch out. Kind of nice way to just do specific graphs. Okay, 10 has got a fine fraction. So A is 7/2. H is +1. K is -3. So they got, okay, this one you had to put in the H. The H that was missing. They went ahead and added 7/2 and a -3. So 7/2 minus 6/2 is just 1/2. So they did that for you. Here they just took H plus 1, and here you just mimic the story. So this is H plus 1. This was H. Beautiful domain of all real numbers. Range came from the K number. You won't have any problems finding your graph. Okay, last one. Oh, wrong direction. I'm all in the fiddle. Let's get number 11 up here. It's no different except H isn't 1, it's 4. So A is a negative 5/3. H happens to be a positive 4. K is a 5. So you put in your H plus 1. That's where that came from. Put it in like you see it. And they asked you for the asymptote this time. So that is K. Since there's a kind of a double 5 thing, don't let that fool you. And then this is K for the range. And again, look for your first point, and that should get you the graph. You guys are done. So double check and turn it in.